Hello, welcome. Today we're going to go over simplifying. The rules for simplifying with rational exponents is that you may not have any negative exponents. You may have no reducible fractions. There are no double bases unless it undoes a negative exponent. Double bases meaning like x cubed over x squared, you'd want to do x to the first in the numerator because you have one extra x on top, or 3 minus 2 is 1. Similarly, if you had x squared over x cubed, it'd be 1 over x because you would do 2 minus 3 is x to the negative first, which turns into 1 over x. Or you could do 3 minus 2 is 1, and the denominator is larger, so it goes in the denominator. The only exception to the double bases is this is not preferred, so because there are no fractional exponents in the denominator. Therefore, you'd have to rationalize, and you'd have x to the 1/2 over x. The double basis is preferred in lieu of a fractional exponent in the denominator. So let's just practice. There are many different strategies that you can use to simplify. I always get it down to 1x and 1y first. So I have x to the 1/2 and x to the 2/3. So I'm going to do 1/2 minus 2/3, so 3/6 minus 4/6 means I have x to the negative 1/6 in the numerator. Then I'm going to simplify my y's. I have 2/3 minus 1/2, which is 4/6 minus 3/6. And I have y to the 1/6. I can't have negative exponents. So I next rewrite this as y to the 1/6 over x to the 1/6. I have no double bases, I have no negative exponents, I have no reducible fractions, but I do have a fractional exponent in the denominator, so I need to rationalize. So I'm going to multiply both the numerator and denominator by x to the 5/6. So I get x to the 5/6, y to the 1/6 over x. And that is my final answer. Try another one. Ooh, this one's hard. First, I personally would get rid of the fractional exponent outside the power of a power. So I'm going to leave my numerator as is. And my denominator, I'm going to distribute this through. I have 4 to the 1/2. 4 to the 1/2 means the square root of 4, which is 2. So I have 2, x to the first, because 2 times 1/2 is 1. Y to the negative 2/6. Okay. Next, what I'm going to do is reduce this fraction to negative 1/3. And then I'll make that a little bit neater. And I have to the negative 1/3. Now I'm going to reduce. 2 over 2 reduces to 1. So my numbers cancel out. I'm going to get it down to 1x. 2 minus 1 is 1. I'm going to get it down to 1y. 1/3 minus negative 1/3 is 2/3. So I have y to the 2/3. I have one of each base. I have no reducible fractions. I have no negative exponents. I am done. This one, I'm first going to get rid of the power to a power. So I have 2 to the negative 2, x to the negative 6/2, y to the negative 2/2. Times 9 to the 1/2, x to the 1/2, y to the 3/4. I'm going to reduce my fractions and help out my numbers here. 2 to the negative 2, x to the negative 3, y to the negative 1, times 9 to the 1/2 is the same as the square root of 9. So that's 3, x to the 1/2, y to the 3/4. I'm going to rearrange my positives and negatives next. So I'll switch colors so you can follow this next step. This needs to go to the denominator, denominator, denominator. So I'm going to end up with this as my numerator, and this over here is my denominator. 3x to the 1/2, y to the 3/4, over 2 squared, ooh, that's 4, x cubed, y. Going up here. I'm going to go 3x to the 1/2, y to the 3/4, over 4x cubed y. Now I need to start subtracting. I'm going to take 1/2 and minus 6/2, which is 3. So I get 3x to the negative 5/2. I'm going to do 3/4 minus 1 whole, which is 4/4. So then I get y to the negative 1/4. This is over 4. Now I need to put my negative exponents in the denominator. So I get 3 over 4, x to the 5/2, y to the 1/4. Oh, look at that vicious circle. I'm going to have to multiply by x to the 1/2, y to the 3/4. And I'll end up right where I was right here. Therefore, this is my final answer. There are no reducible fractions. There are double bases, but it undid a fractional exponent in the denominator. There are no negative exponents. Okay? One reason I would know that ahead of time is that this numerator is less than 1, and it's smaller than the denominator. Less than 1, smaller than the denominator. That clued me into this vicious cycle.